Hello everyone, my name is B Pawan and my AAT concept video for the topic for the subject satellite and microwave engineering is Introduction to Waveguides. First, we have to know what is meant by the definition of waveguide. Then we can understand the briefly about the waveguides. Introduction to a waveguide. If the frequency of a signal or a particular band of signals is high, the bandwidth utilization is high as the signal provides more space for other signals to get accumulated. However, high frequency signals can't travel longer distances without getting attenuated. We have studied that transmission lines help the signals to travel longer distances. Microwaves propagate through microwave circuits, components, and devices which act as a part of microwave transmission lines, broadly called as waveguides. A hollow metallic tube of uniform cross section for transmitting electromagnetic waves by successive reflection from the inner walls of the tube is called as a waveguide. A two-port rectangular waveguide. A waveguide is generally preferred in microwave communication. Waveguide is a special form of transmission line which is a hollow metal tube. Unlike a transmission line, a waveguide has no center conductor. The main characteristics of a waveguide are the tube wall provides distributed inductance. The empty space between the tube walls provide distributed capacitance. These are bulky and expensive. And let us understand the advantages of waveguides. Few advantages of waveguides are easy to manufacture. They can handle very large power in kilowatts and the power loss is very negligible in waveguides. They offer very low loss, low value of alpha attenuation. When microwave energy travels through waveguide, it experiences lower loss than a coaxial cable. Types of waveguides. First one is rectangular waveguide. Second one is circular waveguide. Third one is elliptical waveguide. Fourth one is single ridged waveguide. And the fifth one is double ridged waveguide. Here we can see the types of waveguides. Rectangular waveguide, circular waveguide, single ridged waveguide, double ridged waveguide, elliptical waveguide. The frequency of a microwave signal lies somewhere between 300 MHz to 300 GHz. These waves generally propagate in free space with the velocity of light, that is 3 into 10 power 8 meters per second. Modes of propagation in a waveguide. When an electromagnetic wave is transmitted through a waveguide, then it has two field components. that oscillate mutually perpendicular to each other. Out of the two, one is electric field and the other is magnetic field. The figure below represents the propagation of an electronic magnetic wave in the z direction with the two field components. Here the red wave represents magnetic field and blue wave represents electric field, and the black line showing the arrow represents the direction of propagation. Transverse electric wave. In this mode of wave propagation, the electric field components is totally transverse to the direction of wave propagation, whereas the magnetic field is not totally transverse to the direction of wave propagation. It is abbreviated as TE mode. Ez is equal to 0 and Hz is not equal to 0. Transverse magnetic wave. In this mode of wave propagation, the magnetic field component is totally transverse to the direction of wave propagation, while the electric field is not totally transverse to the direction of wave propagation. It is abbreviated as TM mode. In this, Ez not equal to 0 and Hz is equal to 0. Transverse electromagnetic wave. In this mode of wave propagation, both the field components, that is electric and magnetic fields, are totally transverse to the direction of waveguides wave propagation. It is abbreviated as TEM mode. Ez is equal to Hz is equal to 0. It is to be noted here that TEM mode is not supported in waveguides. As for the TEM mode, there is a need for the presence of two conductors, and we already know that a waveguide is a single hollow conductor. Parameters of a waveguide. Cutoff wavelength. It has the maximum signal wavelength of the transmitted signal that can be propagated within the waveguide without any attenuation. This means up to cutoff wavelength, a microwave signal can be easily transmitted through the waveguide. It is denoted by lambda c. Group velocity. Group velocity is the velocity with which wave propagates inside the waveguides. If the transmitted carrier is modulated, then the velocity of modulation envelope is somewhat less as compared to the carrier signal. This velocity of the envelope is termed as group velocity. It is represented by Vg. Phase velocity. It is the velocity with which the transmitted wave changes its phase during propagation, or we can say it is basically the velocity of a particular phase of the propagating wave. It is denoted by Vp. Wave impedance. It is also known as the characteristic impedance. It is defined as the ratio of transverse electric field to that of the transverse magnetic field during wave propagation at any point inside the waveguide. It is denoted by Zg.